Okay, grade 12, here's a quick video of the last drawing, cam drawing on page 100. So it's a slightly odd one. I'm sure at this point you have done your cam shaft, which is at this point 15 millimeters radius, and you can hatch it like that. And then you have your minimum radius of 15 from the center point till there. And then you have the cam follower, which has been given to you. But at this moment, the cam follower lies horizontal, where it's normally vertically aligned with the center here. It now lies perfectly at 90 degrees horizontal. So your zero starts here. You still have your divisions of 30s and 60s. And your zero starts here. It is anti-clockwise, counterclockwise, so your arrow shows. So the rule is that if it's anti-clockwise, your labeling starts being in a clockwise direction, 30, 60, 90 and so forth, until you get to the original 360 and 0. Alright, so all of those things should be in place. You shouldn't have any problems with that. For you to be able to get the height here, or just before I go there, even the cam displacement diagram, you will find that 8 millimeters in your instruction would be for 30 degrees. So from there to there would be 8. So every little slot here is 8 millimeters apart, which allows you to have 12 spacings to get to 360 degrees. Your height, your vertical height is calculated from the movement. So it says here, if you just fish your eyes on the motions, it rises by 40 and another 15. So 40 plus 15 gives you 55, and then it drops down to its origin again. So you can have the entire height of 55, and that's why you have a maximum radius here. Just remember this end here does not imply basically that is the maximum. Okay, you have to get it from your cam displacement diagram. Alright, so now let's go to the first bullet of your motions, right, where it says it imparts on the following the following motions are being imparted on the follower. Now it speaks about left, and it speaks about right. So if you should have any problems really with left and right, because normally we have up and down. So now it moves, because this is horizontal, it's going to go left. You could simply just turn this page like that and you'd have normality, right? If you don't understand it, but for future references, it's best if you understand left and right as well. Okay, so this is where you are currently at the moment, at 0. So we're going to be talking about left at this stage. You can note it means up, and right means down, right? So, and that's according to this horizontal follower that we have here. Okay, because this follower is going to go left. Left means that way, and it's going to come right, which is down. So left means up, and right means down. That's how it's going to be. Alright, so you are here at this moment. So it says here that it moves left with uniform acceleration and retardation for 40 millimeters over the first 180. So from 0 to 180, which is perfectly there. Right? So from 0 to 180, there's 1, 2, 3, 4, 5, 6 spaces it moves. It's going to go the 40. So you're going to end 40 up over a lengthy period up until 180. So it's going to jump from here till there, but according to the acceleration and retardation. So what you need to do is this space here of 40, you need to divide that space into the same amount of spacings that you have here horizontally, which is 6 here. So you have to say 40 divided by 6 spaces, and that's going to give you 6.6. So Then you're going to measure here. Now mine is not to scale, so I'm going to have, for example, half of 40, which is 20 there, and then I'm going to have 6,6 that side and 6,6 here, and then 6,6 there and 6,6 there. Right, so each block is 6,6, so you can gauge it nicely between 6 and 7 will be 6,6. So that is what I'm going to do. But I'm also going to ensure that I do it on my middle line here. So I'm going to have that all on my middle line rather. So there's the one, there's the other one, this is the halfway mark. So I'm just projecting it onto my middle line, which is there. It's best to do it on your middle line. Now, the first line that I'm going to draw is a connection between the top where it's going to end and the start. So there's my first line, right? And then I'm going to draw lines from here to that point and from here to that point. And this is the process of acceleration and retardation, that you do that there. And you follow the same on top here, there and there. So you've got that construction there now. And then you are going to plot your point. So that's very straightforward. So you draw for a line from where it's going to start until where it's going to end, which is 40 up on the 180 line. And then you draw lines from this point to the respective intermediates here, from there to the respective intermediates, and it's normally two points in between. Now that's your first point, that's your last point there where it's going to end of acceleration and retardation. So now you're going to move on this first line till there, that's your next point, the first line, and then your second line is going to jump up till that one there, and that's going to be your middle point, right? And the same here, you work from this side, that's going to be your second last point there, and then that's going to be your other point there. So immediately you see that curve being formed. So I am going to just first put that curve in faintly there. There's my curve. Okay, beautiful. So now I'm going to just darken that curve, and then I know my retardation is here, acceleration is there. That's done. I go back to my motions. It says here, it moves further left, meaning it goes to the top. Another 15 millimeters, which is going to bring me to 55, over the next 90. Uniform motion, that's a straight line. So for the next 90, so 90s, there are 130, and then another 30 which is 60, and another 30 which is 90. So I'm up until that point there, 30, 60, 90, 330s. It's going to be uniform, which is just a straight line. Uniform means a straight line. So it jumps from there, 15 up. Okay. Then the last one, it moves right, meaning it comes down with simple harmonic. Must underline that. Motion back to the original position for the rest of the rotation. So it's going to jump from there right down to the original position where it started, which is these 2 points, starting and finishing. But now you find that there are 1, 2, 3 gaps here. And with simple harmonic, you need to do the arc, the semicircle arc here and your divisions. So let me do that for you. If I could just grab a compass. Just hold on 1 second. So what you have now is that you've got an entire height now, because it jumps from there right down. This entire height is 55. So you got to take that 55. You got to take the 55 and you've got to divide it by 6. Okay? In fact, you don't even need to divide it, because the arcing will divide it for you. So what you need to do is to find the midpoint. So 55 divided by 2. It's going to give you 27 and a half. So I'm going to just find my half here. If I measure that, 27 and a half, mine is not to scale, so my 27 is probably going to be there. And then I'm going to put my compass point on here, right, and make sure that, and I'm just going to check it, whether it is both sides working out for me. There it is. And I'm going to anchor my compass nicely there, and then hopefully if it's correct, let me just try and manage things a little bit better. Okay, here we go. So that's there. So I'm going to draw an arc like that. Right, doesn't matter if it goes over the border, that arc must be there. And now I'm going to divide my arc. First line is going to be there, and that line I can actually take till there, right till there. And then I'm going to have my 30-degree division, and I'm going to have my 60 down, and then I'm going to swap everything around to have my 30 there and my 60 there. So I've got my 6. So you don't even need to divide it into the 6. What is very important, that's your start, that's your finish, and these intermediate points here, right? Those points, you already have the mid one, so those. So now I'm going to draw lines across like that, just till there, only till there. There it's going to be, and till there. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But I only have 1, 2, 3 here. So I've got to even it up. So what I'm going to do, I'm going to divide, like previous exercises, I'm going to divide each block by half. So 8 in there. That's going to be half, which is 4, 4, 4. And I'm just doing it freehand, but you obviously have to measure it accurately. And then there's my midpoint, there's my midpoint, and there's my midpoint. Now I've divided 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I've got 1, 2, 3, 4, 5, 6. Now, when I drop now from this point, I'm going to move from here to that point over there. Right? Then I'm going to move to this point over here. Then I'm going to move to that point over there, which is my middle, then to that point over there, into that point over there, and then my finishing point. So now it's a very gentle curve that I will see coming out of my plotting of my points. First, I'm going to faintly draw a line and then go over it dark, and this is the only part you can draw freehand on there. And there you have your cam displacement diagram. All you need to now do is to ensure that you take each of these points on the specific degrees and take it onto your main line. So that is 0. The 0 is there already. So just as an example, I want to just give you an example. So there you take your 30. And that 30 is now going to be projected from your midpoint and your main line, which is there, onto your 30. There's my 30. And I have to mark that 30 there. Let me do another one. Let me do the 60 onto your main line like we've done previously. And every time you convert that to the specific point where you need to have it. And just remember, every point that you're going to have, there's going to be this circle here drawn around as the circumference around the center point to create that effect. And eventually, learners, I just want to get to this point here, the last point where it's 270 until 360. Because you've divided this into half, you also have to divide each of these into half as well, right, to make it very accurate. So how do you divide these angles into half? It's very simple. You just put one of these there, and you arc it this side, and you arc it that side there, right? And boom, here is your midpoint. You can draw a line here, and you can do the same for that here, there, arc here, and arc there, and boom, there is your midpoint if you want to. You can obviously do it without it, but it wouldn't be as accurate, and those points will actually be marked on these intermediate points that you have there. Okay, then eventually it's going to come down to what we have here in our memo. So I just want to zoom in, and there you have your acceleration and retardation, your uniform and your simple harmonic. They just did the arc on the inside, but too much traffic here. I would have rather drawn it on the outside like I did, and each one has a circle around it, and then you just formulate the cam profile as it is here. Cool. I hope that clears it up. Thank you very much.